well. So thank you on behalf of all of us. So two words that we've started to hear about that I hadn't ever thought I'd hear as much in education as we are lately is asynchronous learning and synchronous learning. And asynchronous learning is the learning students do kind of on their own, either working independently or watching a recorded lesson. Synchronous learning is what is happening in the classroom, and now our live lessons on various conference platforms. I kind of think of the synchronized swimming when I think of synchronized learning. Everybody is doing the same thing at the same time. And we're going to provide suggestions for you on both of these, but we're primarily going to focus on synchronized learning today and look at what students are doing asynchronously so that they can engage in those mathematical thinking and discourse strategies when you meet with them online. We know, just like Obi-Wan and Luke Skywalker, nothing can replace being together with our students, but we believe these strategies will make it a little bit easier. Can you imagine trying to learn to be a Jedi remotely? And I think that's sometimes what we're being asked to do, make our students Jedis from afar. So today, Grace and Amy will be focusing on helping everyone become familiar with some key strategies that will increase student engagement in mathematical thinking and discourse, learn how to use these strategies while teaching remotely, and we'll end with sharing some best practices, cautions, and resources. So finally, I am pleased to Grace, why don't you get us started?
I'd love to. Thank you, Danielle. Hi, y'all. I'm super excited to be here with you today. No surprise, since you get to hang out with Amy and I today, we're going to start by talking about the importance of routines. And no one knows better than an elementary school teacher the importance of routines. And the same is true using routines in classroom. The same is true online. So how can we leverage our routines that we use in our classroom online with students to develop students' mathematical thinking and reasoning? I was talking to a kindergarten teacher the other day, and she was running virtually small groups with her 5- and 6-year-olds. And she was saying to me that, she's watching them and the Brady Bunch images on the screen. And they were not really engaged in what was going on. And all of a sudden, she started to use a routine that she typically used with them in the classroom. And she said it was amazing. They sat up, their eyes lit up, and they started interacting. And I think that's true. We know the power of routines. So let's talk about whether we're talking about big routines, like routines that are found in the Ready curriculum. Try it, discuss it, connect it. Danielle, can you give a little click there?
Sure can.
Awesome. So like big routines, instructional routines that kind of take the flow of a whole lesson into account, or even small routines like think, pair, share, or using hand signals in the classroom. How can we leverage these familiar routines to engage students in learning? And Danielle, next. Yep, perfect. So if we're thinking about promoting mathematical thinking and discourse in the classroom, more than ever now as we work remotely, we need to be supporting students in learning how to make sense of problems before they jump in and try to solve them. But we need to really be providing students with time to think on their own, to process, and be creating opportunities for students to be talking through their mathematical ideas. So toward that end, we have sort of 4 strategies that many of you probably use some of in your classrooms, and we want to talk about why they're so critical in promoting math thinking and discourse, and how we can use those very same strategies remotely, whether it's asynchronous, whether it's through materials we're sending home or a pre-recorded video kids might be looking at, or synchronous, where we're working in real time with students. And so those 4 strategies we're going to talk about today are the 3 reads, individual think time, turn-in talks, and something we call the 4 R's. So let's get started with the 3 reads. So to begin talking about the three reads, I first want to start and say a few words about what makes reading in mathematics hard. And so now I'm going to talk about reading a paragraph, which is not really reading in math. But if you think about kids reading outside of math, whether it's a paragraph or an essay, there is a typical structure to how we write and the things we read. And that is that if you think of a paragraph, for example, it always starts with like the reason for reading, a topic sentence. And then it works through details, right? Here's the reason for reading, and here's the reason why, and here are some examples. But in mathematics, that's actually the opposite. So when kids read a math word problem actually starts with all the details. And you don't know why you're reading until you get to the very end of the problem, typically, where you get the question you're supposed to be answering. And that question in math is essentially a topic sentence, the purpose for reading. So we would like for kids to get in the habit of reading a mathematical problem 3 times. Because of the way they're designed, you can't hold all those details in your head or know which ones are important on just one read. So what we'd like to do is have kids read a problem 3 times. The first time, just to think, like, what is this problem about? And the second time, to ask themselves, like, so what's the question I'm answering? And now that I know what it's about and the question I'm answering, I'm able to go back and look for important information. So if we look at the problem that's on this page, and a student read it one time, or you're maybe reading it now, and you ask yourself, what's this about? Well, it's about renting a bike. It's about Caroline going for a bike ride. It's about writing an equation. If we read it a second time for the purpose of understanding what the question is we're trying to answer, it's not just a matter of identifying the question on the page, but it's being able to restate that question in your own words. So, I don't know, in this case, if M is going to be what the variable that we're talking about, the amount of money it's going to cost Carolyn to rent a bike, then which one of these equations is going to give me the right value for M, given the circumstance? And then, now that I know the question I'm supposed to be answering, I read a third time for important information. So, Danielle, next slide, please.
Mm-hmm.
So then the question becomes, what is mathematically important information? And when mathematicians read a problem or are making sense of a problem, they read for quantities and relationships, not just the numbers in a problem or keywords, but the quantities and relationships that those numbers and keywords are talking about. So if we go on to the next slide and back to that bicycle problem, often kids would read this problem and notice the 3 and the 6 and the 1 and the 2. They might even circle those. They notice the keyword times. And if they stop there, they're not making sense of the problem mathematically. We want kids to be asking themselves when they see that 3, what is that job of that 3? Is that 3 telling me about a quantity, how much of something I have? Or is that 3 describing a relationship? So we want kids to get to the point where when they see the 3, they're thinking, what's that representing? Oh, that's the amount of money it's going to cost to rent the bike in 1 hour. Or they might be reading and trying to think about quantities that don't have values, like the amount of money to rent a bike per day. We don't know what that value is. It wasn't explicitly given, but it's a critical quantity in thinking about how to solve this problem. And so moving kids to quantities and relationships. Something that's super helpful for kids is to provide them with a note taker where they're literally prompted to read the problem 3 times, like you see here, and answer each of those questions. What's the problem about? What's the question? And what's important information? So that's the 3 reads, but let's talk about how we might use this strategy in a remote setting. And to do that, I want to talk about, well, what if kids are working on their own? What if they're working asynchronously, and what if they're working synchronously? So if they're on their own and you're sending materials home to them, providing a note taker that prompts those 3 reads is super helpful. Encouraging students to be asking themselves questions like, what's this problem about? What's the important information? And providing sentence frames and starters like, the problem is asking, ... or an important quantity is really helpful to cue kids in using that 3 reads to make sense of a problem. Now, if you're working asynchronously and recording a lesson for students, then you're probably reading the problem to them and providing those questions and sentence frames. And it's critical when you're reading to stop and pause and give kids time to respond, or tell kids press pause and write down what the problem is about, write down what the question is asking. Encourage kids to talk through their thinking with a family member or even out loud to themselves. And you can provide sample responses for students to think about afterwards. And then finally, if you're working on the 3 reads synchronously live with students, then as you would in a class, read the problem the first time, have students read it a second or third time, then you're asking those questions and you're providing the sentence frames to get kids responding. And again, critical that you're pausing and giving kids time to be thinking about their response. Students might be sharing them in writing or in a chat box, or you might be calling on them individually to respond. If you're sharing in a full group, again, it could be verbally turning kids' mics on and off or responding in a chat box, or students might write the question they're answering and hold it up to the camera so that everyone can read their question. Or as a student's responding, the teacher might be typing in or writing down, recording on a piece of paper or whiteboard that she's holding up to the camera of her computer so everyone can see. So just some ideas about how to use the 3 reads remotely. So that's a lot of information. What we'd